Well, good afternoon. My name is Eduardo Juarez, and I'm gonna be giving you an introduction to our problem. First of all, let's read it. A cricket jumps with an initial velocity of 2.35 meters per second at 67.0 degrees above the horizontal. It is trapped by a bat and 0.34 seconds after jumping. So, well, as you saw, this is a clear example of projectile motion. But before we start analyzing the problem, we should understand, basically this term, which is projectile motion. So, what does projectile motion is? Projectile motion is basically the motion of an object which is thrown to the air following a path, and that it is only going to be affected by the acceleration of the gravity. So, in the problem, a lot of information is given to us, such as the time, such as the initial velocity, such as the degrees. So, once we have this information, we can start analyzing our problem. So let's do it. We have one projectile, which is the cricket, and this projectile, once the cricket jumps into the air, it reaches an acceleration of 2.35 meters per second. It is worth to mention that when the cricket jumps and reaches this acceleration, he's following his path to 67.0 degrees. And when he's going to that direction, we can see how a parabolic motion is formed. So when the projectile reaches a maximum height, its velocity is going to be equal to 0 and will start falling afterwards. So when our projectile is going to be trapped 0.34 seconds after it reached its maximum height and started to fall. And now my classmates Alexis and Juan Pablo are going to explain how they solve the questions given by the problem and the respective formulas.
Okay, I'm going to explain the answers of the question A and B. The A, what are the X and Y coordinates where the cricket is trapped relative to its jumping point? So we need to find X and Y. So first we have to find the initial velocity of vertical and horizontal sides. So I made this formula and this formula for the vertical. So we substitute and we got for the horizontal initial velocity is 0.918 meters per second. In the vertical side, this formula is substituted. I made the operation, and from the vertical is initial velocity is 2.163 meters per second. So we have to know X. So there is this formula. I substitute. I made operations. Then this is the answer is 0.312 meters. That is the X coordinate, the final position. So for the vertical, we must do more things, because with this formula we cannot find Y. So I made this formula to find the final velocity, and the final velocity is minus 1.169 meters per second. So we have the initial and final velocity, but we almost not have the Y. So there is another operation for the Y. That is this formula. I substitute, I make the operation, and the answer is 0.169 meters. So we found X and Y. So for the second question is, what is the speed of the cricket when the bat trap it? So we now found the final velocity. Okay, So logic is involved the velocity of horizontal and vertical. So this is the formula. I substitute the values, I make the operations, and the final velocity is 1.487 meters over second. So this is the answer.
Hi, my name is Alexis Ortiz. I am in team number 2, and I will explain you the last two questions of this problem, which are the maximum height and the final position of the cricket when there is no bat. Important detail here is that since there is no bat anymore, we need to delay the time of the bat and get the new time, or new times in this case. If we want to get the maximum height, we need to get first the time of the maximum height. So it is given by this formula. Time of the maximum height is equal to minus boy over the gravity. So here are the values. Minus 2.163 over minus 9.8. And the result is 0.22 seconds. And it is right here. Okay, we have the time of the maximum height. Now we are going to get the maximum height that is given by this formula right here. Well, we perform the operations and the result will be this one, 0.238, and it's right here. Okay, we have answered question C. Now we got for the last one. Basically the same, because we have to find the position, the last position, the final position of the cricket. So it is related to the maximum range and also related to the time of the maximum range. So here is the formula, which is 2 times the time of the maximum height, and the result is 0.44, which is right here. And last but not least, we have to find the final position, and it's given by this formula. Once you perform the operations, the result will be this one, 0.404, right here.